Welcome to the channel where we build a game from scratch using Love2d and Lua. We are building a top-down adventure game inspired by Link's Awakening. Now yesterday we got this Corrupted Gecko to start having basics of AI. Now what's happening is it's starting in an idle state and then it's taking a time between 1 and 5 seconds to trigger its walking state. And a walking state walks it off in a single direction and the particle system goes with it. So it'll be a random direction and a random time, but ultimately we want to add more details. It looks like it's just going in one direction. Let me see. It should go in a random direction. Okay, there we go. We just lucked out getting up, up, up 3 times in a row. So it should be a random direction. And the only logic we've got is it goes in a random direction and the direction the gecko's animation is facing corresponds to that direction it's going. There we go. So we just haven't seen down yet, but the particle system is also beneath it. And you can see the kind of festery nastiness once it walks away. There's down. So today we're going to be trying to implement a more interactive AI. Instead of just picking a direction and walking, we're hoping to maybe have some tracking detection. So it's like maybe it always walks towards where the player is. And if we can get that done today, that would be really cool. So we'll try. We'll see what we can do. Now let's take a look at how we accomplish this. Now we have an entity walk state, and it's got a function called process AI. Now what that's doing is it's asking if the movement timer is 0, which is what it initializes to, and then it sets a random direction for, this is the random direction for the entity that gets assigned based on these 4 directions and the random return index of it. And we change our walk animation to be that same exact index as well as its dot direction. And the entity's dot direction is what actually controls it walking off screen and walking in the correct direction. And then we go ahead and increment that movement timer so that we only set the direction once. If we don't do that, we would set, if we don't do this, watch what happens. It'll just set a random direction every single frame. And we get some logic like that, which is to be expected if we keep setting a random direction every single frame. So moving forward, we're going to be trying to give it more adaptive AI, and we're going to try to track our player character and have our corrupted gecko actually walk to where our player character is instead of just walking in a random direction. So we'll see if we can get that working today, and that would be cool if we can. What I'm going to do is make sure we've got our entity walk state harpooned towards the top of our file here so we can access it quick, as well as our entity idle state, which we also need harpooned and also up here at the top. Okay. So how might we go about this heat-seeking AI? First of all, let's go to the walk state, because idle state, all it's doing is waiting a certain amount of time in order to change to the walk state. So let's go to the walk state. Now, instead of, in our process AI function, instead of giving us a random direction, we're going to do something different. So ideally, we do something like, well, let's think about this. How do we, right now, the entity walk state doesn't have a reference to our player. So it doesn't know where our player exists. Now, there is a small caveat in that we have a global variable that's holding our scene. And our scene has a reference to our actual player. But instead of doing a reference to the global scene, I don't know if we want to keep our scene global So we might just see about passing in our player reference into our entity state. Yeah, let me think about that. I don't know what's the cons of moving that. Where do we set our entity's state to turn into walk? Well, it starts here because it starts in idle state, and then our idle state is processing our AI. When we go here, we process our AI for the entity, which is corresponding to whatever scene it's in. So maybe we have to do, I don't know if we add in a parameter for our entity, like we might be able to pass in our player, because this is our scene, so our scene's player. If we put this as a parameter, then our entity would have access to it. We just need to make sure that both of our entity's states have room for a player parameter. So maybe we can go here to both our idle state, and we make sure this process AI function has got a player. And right now we're not going to do anything with it just yet, especially in the idle state, but we just want to see if we're just going to see if we crash here. Like we know that there's going to be a player parameter. Let's just see if we still run. We should run fine. Okay, that's good. What's weird is we started facing up there, which I don't think I ever remember seeing. It's because in our entity class yesterday when we were tweaking it, we changed it to be facing up as a default instead of down. So we'll just go change that back now, and we should instantiate facing down as well as that gecko does. So I'm going to go to our scene, and we're going to manually set our gecko facing up just purely for cosmetic reasons. Once we populate our entity, we're going to go ahead and overwrite its direction to become up. See, like right here, we used to have a default direction, and we're just going to change it to up for purely cosmetic reasons. So the gecko will be facing up, we'll be facing down, and then it'll get a random direction and run. Now that our process AI functions will now have a reference to our player, we can go ahead and add some simple AI to try to get our gecko's X and Y to be closer to, oh, okay. I was seeing why it was only ever going up, and that's because we took out all our logic in our entity process AI. So one thing I think we want to do is give a different function for our gecko AI than every other entity AI. So like we know that because each entity, like for example, we might have a gecko, we might have a bird or a raven or something, and they all might have different AI. They're going to move differently. So we don't want to just go ahead and call it process AI. I think we might want to call it process gecko AI or something. And then when we cycle through in our update function, when we cycle through all of our update for our entities, we want to say like if entity is type gecko, then entity process gecko AI or something like that. Because right now we're just we're running our process AI function, which our other entities will have different AI. So I think we want to make a gecko specific AI here. I'm going to see in our entity class, we don't really have a entity type. We should have an entity type saved as whatever our animations might be. because we want to be able to say, hey, if it's of type gecko, then process the gecko AI. But I don't see a super easy way of doing that right now. Like we could have self.entity type, and it starts off as nil. And then what we go ahead and do is whenever we're in our scene, when we populate our entity instantiations here, once we populate our geckos here, we go ahead and we would take that entity and go ahead and manually assign a string. Did I spell that right? Entities at index 1 dot entity type gets a type of gecko. So now we can say, hey, if entity type is gecko, when we're going to update and process our AI, then we want to process the gecko AI. If it's of type Raven, we want to process the Raven AI or whatever for the other entities. So I think this is a good idea to start to add, and then we can kind of decouple different AIs all within our entity system. So we want to go to our process AI. Okay, so here's something that's a little different too. If we call process AI on our entity, it's actually going to go to that state machine's process AI. Okay. So we might want to keep our process AI named the way it is, but we might want to go into here and then say, if we're not passing in the entity here. No, we are up at the top here. We have a self.entity. So we could say if self.entity dot entity type, and maybe we just put it as type because a .entity type is a little redundant, is equal to gecko. We want to do something. So maybe we just say type. So our entity class would have to have a type field that we not only define here upon an initialization as nil, but when we get to our scene and we actually instantiate our entity, our gecko variety here, we go and say just that entity's dot type is now equal to gecko. And now in our scene, we're going to be calling process AI on our entity. And what that's going to do is say, okay, well, what state is that entity in? And go ahead and run process AI on whatever state that entity's in so that we get different behavior for the walk state and the idle state. And then we can ask what the type is and do a certain thing to that entity. So like, let's just see if we run our game right now, it should only go, our direction should only be up because we're not actually changing the direction that it's facing by the time the walk state kicks in. So I want to see if our entity type is working, and we can say, you know what, our dot entity direction upon a walk type change, our entity dot direction here is going to be equal to a right direction, which should move it right. And then we also want to change its, we want to say entity change animation to be equal to the walk animation concatenated with a toString version of that entity's actual direction. Now for right now, since we're not keeping this, we can just put in a string of right so that we actually change it. Now, what are we missing here? What are we missing? Oh, not testing for equality, but assignment right there. Okay. Okay, we should move right, and we do, and the animation turns. So we do have an entity type of a gecko that we're doing specific logic for. If we change this to anything else, like if this is bird or whatever, then we should walk up because it's not a type gecko. Yeah, okay, cool. So we'll go back to our gecko type, and now we kind of have, we're going to process AI based on whatever entity type we are. I don't know if this is the best way to do it, but since it's a little confusing, since our process AI function has to run through a couple different things. We're running it in our scene for each entity, right? So then it's saying, okay, well, how does this entity process its AI? Well, it defers it to the state machine. So then it goes to the state machine. It says, okay, a dot state machine AI, process AI runs where? And it says, well, it depends on which active state machine we're at. So then it asks, okay, well, what active state machine are we at? Are we a walk or an idle? Then if it's a walk, and then it goes to this walk state, and then it runs the process AI function here where it checks its type. So I don't know of a better way to kind of run, because we don't really, ideally we just say, hey, entity, process your AI, do your thing, you're good to go. And then it'll say, okay, well, depending on the type we are, we're gonna go either do gecko logic or bird logic or whatever. So I think this is okay, at least for now. So we've got access to the type, we're changing its direction. So let's go ahead, now that we should have access to the player, let's make sure we're passing in this player parameter into our state machine once we set it up. Now, we don't pass in the player to the walk state itself, and actually, yeah, maybe the entity walk state. So we can either pass the parameter into the process AI function, or we can pass it to the actual class of the state machine. I don't know what is a better idea. But when we process our AI, we are passing in our player here. So I think that's okay, because if we look at our entity, it's gonna, our process AI on our entity is going to then defer that call to, and we need the player here. So we give that player here so that it can pass it to the actual state machine's process AI. And then when we're in our entity walk state, our process AI is actually having that player parameter. And then we can actually, and maybe what we do is, maybe we can just try, instead of making it walk right, can we just modify our entity's X position to be equal to our player's X. Now, I feel like we want to save this as, I don't know why I would want to do this, but I don't know if we can index into the, I don't know if we can do this, but this is why we're testing this. But I want to say, you know what, let's just do this a local variable. So what I want to say is that we have a variable called player X, and we're storing into it the player object. So yeah, let's do, yeah. This is going to look a little gross, but we're going to set our entity's X. So our corrupted gecko's X is going to be set equal to our player X, which is actually a player instantiation at its .x. It's a little stupid, but I just want to see if we can do that. So as soon as we become a walk type walk, we're not able to index a player X. So can we do the player.x here, store that into player X, just do this? No. Oh, index local player, a nil value. So we're not passing our actual player appropriately. We could use our global scene view object because that has reference to our player, but I don't know if we want to keep our scene view global, so I'm not exactly sure that's the best step moving forward. So ideally, I'd like to be able to just pass it through the functions here. So in our entity class, we're going to look through and make sure that we are passing in the player, and it looks like we are, because whatever player parameter gets passed into the entity process AI function, we're going to be running the state machine's process AI on that exact entity. And that looks like this, where we set our player equal to variable. Now, if we just do this and we don't even bother trying to do anything with that value, does it crash? It doesn't look like it crashes. So can we set our entities X equal to that test X position? Our test is a nil value. So player is a nil value as far as this is concerned. So how come entity walk state is not getting our player that we pass in from our scene? We have our scene, we pass in. Are we passing in? Yeah, we do have a self.player of our scene instantiation, which we're passing in as the process AI function on our entity. Then in our entity, we're taking that player and deferring it to our state machine. And our state machine, oh, you know what? We got to go to our state machine. And we got to make sure our state machine has access to that parameter as well. Yep. So we got to say here, player, and then here, player. Okay. Let's see. Let's hope we don't crash here. Let's see. Okay, hey, look, our X turned to be our player, so we have access to it. That is great. Okay. So, let's do something more interesting now. So, okay, how do we go about this? If we think about what we want the AI to do, the player and the gecko are going to have different X and Y positions. So we need to just move the gecko's X and Y position slowly to be equal to the player's X position as it updates over time. So how do we want to do that? If we want to consider, we could do something very rudimentary like, hey, if our gecko's X is greater than our player's X, move us to the left by a certain velocity. But if we scope that out and we say, okay, well, if our gecko's Y is greater than our player's Y, then go ahead and subtract velocity from our gecko, moving us up closer to our player. But if it's to the right and the bottom of our player, it's going to have our same normalized vector problem. So we need to normalize our vector if we're moving two directions, which is going to be a little tough. So let's give us a local velocity. And we're going to set it equal to 0.5. And all we're going to do is, if our entity is of type gecko, we're going to take our entity, we're going to move its X to be equal to its current X minus velocity, which is move it to the left. But we only want to move it to the left if our self.entities X is greater than our players.x. So we're going to say, and I don't like reusing, we can't really reuse the parameter name because our function here has a parameter called player. So what if we say Tashio becomes player, and we're going to say Tashio X here, which is our player X. I just get errors if I use the same name as parameters. So if our entity's X is to the right of our player, then we're going to move our entity to the left. And that's all we're going to do. But the thing is, we do have a direction. We do have a direction for the gecko, and if we look at our entity class, our direction is causing us to move. I thought it was in our entity class. It would be in our walk state. We want to go to our walk state and look at what our direction is actually doing. Okay. See, look, we're adding a walk speed based on the direction. So, this is just an easy way for us to say, if you're facing left, walk left. If you're facing up, walk up. And if you're not walking, you're in idle state, which has a direction. So we could just change our direction based on certain things, but we would be overriding our direction. Okay, now let me think this through. Let's walk this through and try to do changing it based on our direction and watch what types of errors come up. So, like if our entity is to the right of our player, then we're going to say, hey, our entity's dot direction is going to be equal to left because we want it to move left. So we're going to say this. Now this doesn't allow us to use this velocity, but I just want to see something. Okay. Yeah. Now what it doesn't do is move to the right if it's further right. So we can say, okay, well, if we could say else if our self.entities x is smaller than our player's x, then we want to move it to the right. So we would say self.entity.direction is equal to right. So let's see that. So it'll take up to 5 seconds to kick on the AI. And then now it is actually tracking with us. Only on the left, only on the X and left and right. Wow, okay. Okay, this is a little creepy. It's a lot creepy, actually. But this is the problem. So, okay, so now let's do it one step further, and we could say, okay, well, let's see if our entity's y is smaller than our player's y, and if our entity's y, that means it's above us, so we'd want to change our entity's direction to be down. So we'd say self.entity.direction is equal to down, and then what we can do is say otherwise our entity's got to be facing up. So now we should have four-way tracking, and I want to slow down. I want to slow down how fast we're moving. So our entity's walk speed is actually going to slow down. I don't want them to be moving as fast as us, so we're just going to slow them down just a bit and see how that looks. So now it's going to take 5 seconds to click on, and it's okay. Well, we spelled entity wrong. Now I don't even see where we spelled it wrong. What line did we spell it wrong? Entity walk state 57. Okay, so one more thing. We don't want to do this in a else if, because it's going to block. It's going to only limit it to one direction when we want it to be able to move diagonally. Now we still have to normalize our vector. But this should get some basic AI tracking on our character here, on our Corrupted Gecko. If our entity .y is greater than our Tashio, meaning our Corrupted Gecko is beneath us, then we want to walk up. Okay, so now we should have some basic AI. After 5 seconds, it'll click on. Oh my god. Yeah, okay. I mean, it is working. It really is working. It's not changing the direction. Actually, I kind of actually really like this. It doesn't walk diagonally, but I think it's creepier when it doesn't. So we wanna make sure that our animation changes appropriate to what direction we're moving. So we can either do that in our update function for our walk state, which I think is the way to do it. We want to say, you know, if our direction is a certain way, we want to say, hey, our entities dot, or actually we want to run the change animation function on our entity to be the walk appropriate direction, which is this case is down. And then we want to take this and do it for every direction. And this is our walk right. This is our walk left. This is our walk up. And now the animations should match whatever direction it's walking towards to come track us. Oh my gosh, yes. Oh my gosh, yeah, this is creepy. This is really creepy. Yeah, oh, it is very creepy. I like how it doesn't, I actually like how it doesn't go diagonal for us. It just, oh gosh, it just feels, I don't know, it feels really creepy that he's like methodically kind of going for us. Oh my god, it's so creepy! Okay. But right now we're rendering our gecko in our scene, so if we walk off, our gecko will still be on our scene. So that is even weirder. Oh, that is so strange. Wow, that is so weird. Okay, I'm really happy we got this basic AI working. And it allows us, we can scale it to different sized or different types of animals. Do we want it to move diagonal? Now it's tough because we don't have diagonal animations for it, so I think the directions we've got for it actually work quite well. So I think the next step is to add collision detection, right? Because look at that. I mean, that should never happen, right? Oh my god. Oh, it's so gross. So he does follow us, but once he gets to us, you know, we need to add this collision detection so he doesn't just sit on our face like this. As much fun as it looks. Yuck. That's so gross. Okay. This is looking good, though. So we need some basic AABB collision. Oh, and see, why did he freak out there? Wow, okay. I don't know why he does... That's strange. So if I hold 2 directions... Oh gosh. This is weird. If I hold multiple directions, he just kind of flips out. I don't know what that means. Wow, that's really weird. I don't know why multiple directions would make him flip out. I think it's because every frame our player's being updated if a direction's being held. Well, I guess it really depends on the order of operations for our input handling. Yeah, whenever we hold 2 directions or 3 directions, it gets jacked up. This is strange to me that it would ever do this. It doesn't, like, maybe we print up what direction it's facing, because it doesn't even... This is weird. Because we should only be... let's take a look. We're changing the animation based on the entity's direction. That makes sense. But then in our process AI, we're changing our direction based on maybe... I don't know why it's messing up like that. For multiple directions, like it... Maybe... I don't know why. I don't know why. But there is a value here where when our entity is equal to our X position, that we're not actually changing our direction. So maybe we just need to add a greater than or equal to or a smaller than or equal to on either or on both the left and right and up or down, so that we're inclusive of all the values it could be. Because if we're just asking is it smaller than or greater than, we're leaving out the is equal to in those scenarios. And if it's equal to, it needs to know what direction to change it to. So, well, that's jacked. So this is part of the problem. Okay, so this is part of the problem. If our entity is beneath our player's X, then we're going to go ahead and become left. No. If our entity is to the right of our player, we're going to change our direction to be left. If our entity is to the left of our player, we're going to change our direction to be right. If our entity is above our player, we're going to change our direction to be down. And if we're above our player, actually, if we're beneath our player, we're going to go ahead and entity direction up. That is so strange. Why is multiple inputs screwing that up? Because you would think, and let's see if our player X gives us any clues onto what it might be causing that. Now we do have, if we look at whenever it's flipping out like that, we do have a floating point value for our X and Y position. So we might have to round. Yeah, I think that's the problem, because when it's comparing, our gecko is comparing our X and Y value to the player, And since our gecko is only ever being updated to an integer, I think it is alternating between, oh, I'm beneath him, oh, I'm above him, oh, I'm beneath him, oh, I'm above him, and then it gets stuck. Because as soon as those values become integers, it works fine. So maybe we just need to flush, or we need to, round down and truncate our x and y if multiple inputs are held, and maybe it'll cease that weird behavior. So let's go into our player class, and we'll go to our multiple input handling. Let's see here. I don't know where we're doing this. I don't know if it's in our player class. We need to leave some better notes for us, because we need to be able to find things like this. This is just updating our input list. This isn't actually doing our input checking for our direction, I don't think. So I don't know if that's in our scene or what. Yeah, not in our scene class. Player walk state is where it is. Okay. Okay. Oh, gross. Okay. Yeah, this is it. So if we are holding multiple inputs, we need to truncate our x and y position. So let's do that. If input list is 2, yeah, if we're holding more than one input, we need to go ahead and see. Now we can't quite do this too. Hey, K-Tronics, what's up, dude? What's tough is, since we're doing a Game Boy resolution here, our character's update, like our velocity, is smaller than 1 pixel worth every frame. So if we go ahead and just truncate our x and y position here, we actually won't be able to move our player. So we can't quite do this. It's like we've got to do it. Let me see what happens, because look, if we put our player.x gets assigned to be a math.floor, so we're going to truncate our player.x, and same with our player.y. And if we truncate both our y and x, if we're holding multiple inputs, let's see. Yeah, that's some weird shit. Yeah, see how we're not moving whenever we have multiple inputs held? Or moving in the wrong direction. So we're either not moving or we're moving in the wrong direction. So we can't quite floor it here. Exactly sure what to try. Because we can't. It's really tough. Because if we round, if we like, see how when we move diagonally, we do have a decimal point of precision. Because if we didn't and we just floored it to the nearest pixel, we wouldn't ever be moving because our velocity isn't bigger than a pixel per 60 frames a second. So we can't just floor it there. But if the instant two inputs are being held, we round it, it might prevent this weird... I mean, I don't know what else would be causing this weird behavior from our gecko, because it's asking, like... And let me see, I think if I'm holding left and right and this issue's happening, I think if I hold up and down, this issue wouldn't happen. But let's see. Yeah. See, if I hold up and down, it's fine. And that just has to do with the order of operations. We're checking the process AI. So I think up and down is fine because we're doing that after. Does that make any sense? Like, you know what? Maybe we nest both the left and right and the up and down together so that we only do one of these things. So we can even leave so if our gecko's to the right of our player, we're going to go ahead and set it to left. Otherwise, our gecko's to the left of our player, so we're going to go ahead and set it right. And then same thing with up and down. I don't know if this will make a difference. But let's try it. So it takes 5 seconds to kick on. It'll kick on its AI, and it'll see it's still doing that weird shit. So it's doing that because it's detecting. Yeah, I mean, and this is at a pure integer, so it has to do with setting this. If our entity's x is greater than let me see if putting an equal sign would even make a difference here. I mean, the other alternative is we don't go based on the direction at all. We just update its x position and then we change its direction. Well, I don't know. It's like we've got to change the animation based on whatever direction it's moving. And then we're actually doing that up here. If our direction is down, we're changing our animation. So we're actually already doing that. So I think we had better luck when we had these split up. But if I were to switch this and we check up and down before left and right, I think it wouldn't mess up with left and right inputs being held, which it is looking like it isn't. But it might mess up if I hold up and down. Well, yeah, see, now it's the opposite problem. So it is, well, at that time it didn't mess up. This is really creepy. I don't like how he tracks you like this. It is very creepy. Okay, well, I can't even... Okay. Sometimes I can get it to mess up, but that is just weird. I wonder if we print up what direction it is, if it's constantly changing, because I think that's what's happening. Let's print up what entity direction currently is, and we'll see... We're going to print up the entity's direction. And when it flips out like that, I think it's switching from direction up to down and whatever. Over and over and over. Yeah. See, it's switching between left and right and left and right. So it doesn't know which direction to move when it should be going down. It shouldn't be going left or right. It should be going down because it's above us. So maybe... So it's switching between left and right when it should be going down. So it's like... I think that means our gecko's x is equal to... Yeah, maybe what we do here is say, yeah, maybe, okay, maybe we lock in these directions only if the other direction, let me see. So like, first thing we do is say, okay, if our gecko's to the right of us, turn our direction left. Otherwise, but then we can say, okay, well, if our entity's x is equal to our player's x, then we're going to see if we need to move up or down. Then we can say, okay, well, if our self.entity y is smaller than our Tashio y, then we're going to go ahead and become entity down. And then we can say we're still going to have the problem if it's equal to the y position, if we're equal to our entity on the vertical. Let's see. Okay, if our entity's to the left of our player, we're going to become right, and we check. And we say we are checking our entities on the right of us. We're going to go become entity direction left. If our entity's x is the same as our player, then we're going to check if we need to move up or down. Then we're going to see if we need to move up or down. Then we're going to say, okay, well, if our entity's to the left of us, then we need to move right. Let's see what that looks like. Okay, I'm holding multiple... Okay, well, holding multiple inputs is jacked up when we're beneath him, but not when we're on the side of him. So, I don't know what to do here. Because ideally, we only change it to be one direction based on whatever... like, we only ever want it to change to one direction, depending on its position. So, we need to find if it's... I don't know. I always spell entity. Not an entity system, it's an entity system. I saw him flip out there. Yep. So why is that? He flips out because he's not to the left of us or to the right of us? Or he's... I don't know what the move is here. Maybe we need to figure out how far he is from somebody. Well, if we change the logic so that the direction he moves is the direction that puts him instantly closer to us, rather than trying, because right now he's just trying to get to be our X position before he actually moves closer to us. So maybe we change it so we first get like, hey, what's the biggest difference in pixels, and go try to make that difference bigger. Like if like we have an X difference and a Y difference that we calculate, and if the Y difference is bigger, then go ahead and try to close that gap. and we do it based on that direction. Like maybe that's the next tactic we try. It's close though. Like I didn't notice it was a problem until I started playing multiple inputs. And then obviously that's just cursed. Oh God. That is so gross. Ooh, and then all the entity goop it leaves behind. That's just disgusting. Yeah, let's try to do this. So what we're gonna do is calculate an X diff and a Y diff. Now, what we're gonna do is we're just gonna subtract I guess we can take we want to take the absolute value of the difference, I guess. Well, I guess it depends, because if we're above it, I think we want to. Yeah, our X difference, we don't want to just do... Yeah, K-Tronics, I am feeling much better today. I got plenty of sleep. I slept like 12 hours today, so I am feeling better. And just the fact that we're like actually getting stuff done today, even though it's broken, but that we're actually making progress, it's easier to keep chugging along. But yeah, thanks for being here, man. It's always fun to have you in chat here. How are you feeling? I know your day was a little iffy yesterday too, like mine. Nice. Yeah, I feel the same way. Although I am trying to figure out how do we find the difference between the X and the Y. We can't just subtract one from the other, because if one is above the other, we'd get a different value here. So it's like we want to subtract the bigger number from the smaller number. X minus Y, operation subtracts the value of Y from X. I think I feel like we're gonna run into the same issue where if they're equal to one another, it's not gonna know what to calculate. I guess... I know, the dreaded 0. Can't divide by it, can't do shit with it. Let's try to print up this X diff and see if it's looking correct. So like xdiff is just the difference in x positions from our entity as well as our gecko. So we actually want this outside. So we can actually print it up. Yeah, and this should only ever be a positive number. Okay. Yeah, we want to make sure, we want the absolute value of it. Okay. So yeah, so the idea here is we get the difference in x and the difference in y, and whatever the biggest difference is, that's direction our gecko first. But then I guess if it's at a diagonal and we do this, if the x difference is bigger, it's going to move left. But then once it gets close enough that the y difference is bigger, it's going to move up, and then it's going to move left and up and left and up and left and up and just go diagonal like that. So I don't think this is what we would want to do. Let's see it in action though, like I'm kind of curious. What's going on? I keep recording a freaking macro. Okay. Why do we have that many blank lines? Okay. Want this to be 10 pixels lower. Okay. Okay, so now we want to set the direction not based on an order of operations between asking its x position, but we want to be we'll say if our x difference is bigger than our y difference, then we're going to go ahead and change our direction to be whatever direction it needs to be, which is if our entity's x is greater than our Tashio x, then we need to become a self.entity direction gets up Otherwise, we're walking down. And then, otherwise, from our X and Y diff, if our Y diff is greater, then we're going to check our Y positions and see if our entity's Y is beneath our player's Y. And if so, then our entity is now going to get a dot direction of, yeah, this is totally jacked. This was, if our entity's X is to the right of our player, we want to face left. Otherwise, we want to face right. Then here, if our entity's beneath our player, then we want to face up. And otherwise, we want to face. That took me way too long to find. Okay. Let's see. Yeah, see? There's that diagonal talk I was mentioning. Yeah. I knew he would do that. Because it alternates every frame whether or not to go. It's like I gotta get close to him, so I'm gonna go in the direction that is the least difference. Oh god. It's cursed. It's freaking cursed. That is so gross. Okay. Yeah. Yep. Well, this is disgusting. Yeah, so that idea does not work. I'm glad we tried it. Glad we tried it. It's weird that it only jacks up when we're holding multiple inputs. And I think it's because, yeah, I don't know. It's almost like I don't know. Because when we floor our X and Y, we're doing that under our input list being equal to 2. It doesn't move us correctly. And I'm wondering if we only ever floor our position upon an input list being 2, only the instance it's being held. It's hard to explain. Let me see. Gosh, I just itched my eyes and then now I'm like, my eyes are way itchier now. So let's see what this looks like again with we've got them all in a shared if block, else if block. And it's going to go ahead and it first tries to match its X position. So if we were to be way to the right of it, yeah, it tries to match the X position first and then it'll go for the Y. And we could, gosh, that's so jacked. Okay. I feel like there's something I'm missing that can fix this really easy. I just don't know what to do. Because it's getting screwed up because it doesn't know whether to move left or right because it's moving left and then moving right because of the, I want to say because of the floating point values there, but I don't know for sure. I don't get why it's doing that. If I understood why it's doing that, we could be able to fix it easier. So if it's constantly switching between left and right, then it has to be coming both greater than and less than the Tashio's X dependent on the direction. So maybe what we do is if I want to say maybe we can check our global input list and say if our input list is 2 inside of our entity walk state, if our input list is equal to 2, then our self-direction just gets whatever our last direction inputted was. So maybe we can try that. So how we might do that would be we've got a global table called input list that is the string of whatever directions are being pressed on our keyboard, on our arrow keys. So we can say if our input list is equal to, if the values of our input list are equal to 2, then we're going to go ahead and set our direction to be equal to the last value of the input list. So that would look like we would take our input list, oopsie. Come on. Okay. We would take our input list and we would index with brackets into that index at the index of the number of how many values are in there. So that'll give us the last inputted string of our buttons pressed. So check that out. If I hold multiple inputs now, well, I just did it for inputs 2. If I hold 2 inputs, it doesn't flip out. So maybe we say if inputs list is greater than 1, then go ahead and set the entity's direction to be equal to the last input list. Well, actually, and that's jacked up because we don't want to move. Oh God, yeah. Okay, we don't want to move our. We don't. This is wrong. We don't want to move our entity based on the direction of what direction we pressed. It's just that if our input list is 2, we don't want it to be. And maybe this means, I don't know, maybe that we floor our entity's X position? I don't know. I don't think this will fix it at all. That's greater than or equal to 2. I mean, it stops flipping out, but it stops if we have more than one input. It's just not, it's not up. Oh God. Oh Jesus. Okay. I don't know what we do here. So why would it be flipping from left to right if we hold multiple inputs? Now, maybe the very frame we hold two inputs, we floor our X position, because we don't want to floor it every time, every frame two inputs are being held, because then we don't actually move. But the very first time two inputs are held, if we floor our X and Y position, I think we might be okay. We just have to make sure to... Yeah, it sucks. It sucks because we're trying to limit our global functions, our global variables. See, we've got... Do we have like a multiple inputs for our list here? Because what we're trying to do is only floor our X and Y value, the very frame two inputs are being held, but then not after that until inputs are released. Gosh, this is jacked up. But there was also a time where we saw the gecko flipping out even though our X and Y positions were integers. So yeah, that's weird. See, like that. Well, no. Okay, well... Because, yeah, we don't want to floor... I wonder where our perfectly contradictory input handling is when we do... But what's really screwed up is if we hold three directions... Oh, actually, that was okay. Well, okay, that's... Dude, I don't know what's going on. If we're beneath him, he'll flip out. It's just so weird that he's changing direction based on inputs that aren't being changed. I don't know if that has to do with the order. Maybe in our scene here, if we render our entity before we render our player, or actually we're not render but update. Maybe if we update our entity before we update our player instead of after, it might solve this. Okay, multiple inputs held. That's okay. Let's try it on the bottom. Damn it. Damn it. I was really hoping that would be it. Because it's weird that it would be... Because I think what's happening here is on one frame, let's say it's moving left, its X position is 78. Now it checks that the player is to the left of it, so it says, okay, I need to go left. So I go ahead and walk left, I update my position. Then the very next frame, it's at 77. And that frame, it's like, oh, the player is to the right of me, so I need to go move right. So maybe we just need to boost that little window instead of just, hey, if it's directly left of us or directly right of us, we give it a little bit of a buffer there. It can be within a 1 or 2 pixel window. It doesn't have to be the exact pixel we're at. It just has to be within 2 pixels of our X position in order to move left, and then that might solve our weird problem. But then it still has to choose which direction to go. Okay, well let's see. Let's go right here. Instead of saying if our X is greater than, if the left side of us is greater than the right side of our player, we're going to say if it's greater than the right side of our player plus a 1 pixel buffer. And then if the left side of us is smaller than the left side of the player plus a 1 pixel buffer, then change the direction. Let's see. Let's see. Still jacked. If the left side of our gecko is greater than, let's see if it's greater than the right side of our player, then go ahead and walk left. And we'll put this back to here. Let's see. Because now it should walk up towards us. Yeah, when it's... Okay, that's still... Okay, it doesn't look like it's doing it. Yeah, it doesn't look like it's doing it. Because the first thing it's asking... It's fine with walking up, even though... Okay. So the... Let's try to shrink this gap as much as we can. So the issue was it was flipping out because it wanted to be exactly where we were. It wanted to be with an X equal to us. So when we were holding multiple inputs, our X and Y position weren't an integer. So it was trying to make us to be the same integer, which it couldn't be because it could only add its velocity, which is once its velocity is added to its X position, wasn't the exact floating point decimal place of our player X, because even though it just says 50 or 80.6 right there on our X, we're actually only printing it up to a 1/10 decimal place precision, but it really is a floating point of a bunch of different values. So we got it working. He is now the thing is, we have to decide if we want it to be like there. It goes to match our X before it goes to match our Y, which if we imagine a more complicated level with a bunch of things like this where it needs to detect collision. It needs to be smarter than just going left. It needs to be smarter than just trying to go left to match us, because once it's colliding with those objects, it won't be able to get away with that. It'll just walk into a wall forever because it's trying to meet its X to our X. So we have to figure out a smarter way to kind of teach it how to find us, especially if there's collidable objects around. So that's gonna be quite a thing to figure out. And then we can work on getting our spell casting. See, and I think something like this, can be exploited because he's just going left and right. So it's like, oh, look, he can never get closer to you if you just go left and right. Then you can sit here and spell cast his ass. Well, it is hard to to play that round. So maybe that's okay. Because the game is kind of tough. Like, you have to balance a bunch of different stuff. So maybe it's okay that he's kind of stupid like that. But if he's got and maybe that's where we do it. It's like, maybe if he collides with a collidable map object, he has to pick a different direction. And then at that point, we get the X diff and Y diff and says, okay, well, actually, we know since he prioritizes left and right, we would just say, hey, just make your Y closer to his Y. But he could get stuck in a corner and then just permanently walk there, and we don't really want that. We want him to be able to be smarter. That's going to be tough. It is really cool to see him have this basic AI, though. It is really cool. So next on the list, we're going to be adding collision detection so that once he collides with us, we lose a heart or, lose some health. And I want it to knock us back in the direction that he kind of hit us. So if he comes at us from the left side, we're going to move us to the right. If he comes at us from the top, he's going to bounce us down. That sort of deal. As well as make us flash red. Hey, Evil Hero, good to see ya. Yeah, so I think maybe tomorrow I don't know what to work on next, because we know we're going to need the collision detection for our entity, so that, and right now we're spawning it only in the scene, but what we really want to do is give, oh, look at us, our walking animation. We're stuck in a walking animation. I don't know why that happens sometimes. Maybe we need to flush our walking cycle if no inputs are held, for sure. But we need to change it to an idle state of whatever direction, which is what we were supposedly doing upon a finished transition. And that is once we initiate a scene transition, like walking from scene to scene. So we need to, instead of right now, we're just putting a gecko in our scene, we need to have like our map declarations are global, we need to be able to put entity declarations in certain scenes, so that if the gecko's here chasing us and we walk off, the gecko remains on that first scene that we left him at, a lot like Link's Awakening. And then that means if we come back to it, he kind of gets reset to his old position, kind of like those classic games. So we'll need to do that so that the gecko isn't coming with us to other scenes here, but that he remains on whatever scene he's instantiated inside of. And then we can work on that collision detection so that he doesn't just walk over things that he shouldn't be able to walk over, like the tree here. And then once that's done, we can work on our collision detection so that we can get hurt and lose some health if he actually touches us, as well as flashing us red and bouncing us the other direction. and then we can worry about spellcast collision detection for our spellcast entities and him, which would do the similar thing, which is make him flash red, make him bounce back if he collides with our spellcast entity. And then ultimately, once his health is down past 0, we don't kill him, but we purify him into a normal gecko again, and then he runs away, which also needs its own AI, so that he doesn't just run into a house forever and ever. So we'll have to figure that out. That's gonna be tough to get a smarter AI that can navigate around objects. So I'm kind of curious how we're gonna figure that out. But I think that's good for today. We've got the AI system implemented, a very rudimentary version where his X position is matching ours, and then he goes for the Y to go touch us and kiss us and do horrible things on our face. So I will check out what our git commit was, and we might, you know what? Yeah, I want to keep these just because if we want to mess around with some. Yeah, let's keep this old logic just in case until we're a little happier with our current AI system here. And then I think that's an okay speed, at least for right now. And we do want to deinstantiate our entity if it goes off screen. We need to do a better job at that, though. Because we need to add the left and right as well. Okay, so what we did was we gave our entity class a type. So we've got the ability to run specific AI for different types of entities. So a gecko might have this logic. A raven might ignore all of the collidable map objects and just go straight for us. So we've got that ability. Now that the entity has a type, we gave our entity process AI function access to our player so that we can actually move our entity with AI closer to our player. So we're passing it there instead of passing it the global reference from our scene view, which I think we're going to ultimately change at some point. So I'm glad we passed in manually the self.player, because I think our scene view will not become global in the near distant future. I don't get why this is green. We didn't add this. Oh, we just changed the order. We render our player after we process our AI, which didn't end up making a difference, but we did it anyway. We added the player parameter into our state machine's process AI so that we could pass it to our actual state machine, which we gave it to our entity idle state as well as our entity walk state. And then we handle the animation changing upon the entity walk state update, so that whatever direction it's walking has the corresponding walking animation. We slowed down our entities by about half, and then we added our process AI for a gecko entity. So like right here, we're saying if entity type is equal to gecko, go ahead and do the gecko entity AI. But that's it. So we'll do a git add everything to the staging area, commit with a message saying simple corrupted gecko AI. And then we'll call it a day. So I think tomorrow we're going to be doing maybe collision detection for our gecko entities and us. We might also move our entities outside of our scene and into a global declaration for the certain maps that we're on. We might change so that our scenes are a class instantiation that have a map declaration as well as an entities declaration. So we might try to handle info like that. I don't exactly know yet, but that'll probably be tomorrow. And then if we can get the collision detection working, then hopefully we can get flashing our character red, or at least an outline of red or something, as well as knock us back upon being hit and decrementing our health. So we'll need to add health to our game very soon, which means we'll probably need to add a little death animation and a game over state. And then we'll have to worry about how to reset our game state upon a death, which would involve reloading our map that we died on, or reloading like a home base map wherever you saved the game, which we haven't added the feature to save yet, so that'll be a whole nother thing. I have done a high score save in the Joust game I built, so I think I would be able to have a couple of variables that we know are relevant, like, hey, what's the current scene? What's the last scene we saved at? What was our health like? What was our magic state? Like, how many spells did we have? What elements did we have? Save all of those things if we initiate a game save, and then be able to load it upon starting the game, as well as load it upon a game over scene. So we'll be working on that. Probably not in the too distant future, because if we're going to be dying, we need our player to reboot into the last time we saved, or a default scene with a default health. So right now we're just in our scene 1-2, because that's what we're changing our scene to, as well as we're having full health. We don't even have health right now, but so maybe we'll add that, or maybe we'll wait a little longer. I don't exactly know, but that's what's on the list for the next couple days. So I appreciate you guys watching. I hope you guys all have a good night and had a good day today. I don't have anyone I can raid. Yeah, you're very welcome, Ktronics. I'm trying to get the badge for doing like 100 raids, so I do want to be able to raid somebody just to kind of get that going on. So Pirate Software's Ferret channel is always streaming, so we'll just give them a quick raid. I don't expect, feel free to leave or not go over there if you're not into it, but you can say hi, look at the cute ferrets, and then go find someone else to watch. But I appreciate everyone watching. I hope you all have a great night, and I'll catch you later.